First question. Compare the roles of the innate and adaptive immune systems in defending the body against the pathogens. Evaluate the importance of their interaction in producing an effective immune response. Now, these 4 questions that I selected, I'll call like some sort of like a mother question, which means in any time, in any circumstances, you may get a question style of those, but let's slightly be modified. But the way you need to answer those questions, it would be very similar to the answering these 4 questions. So I strongly recommend you to make the sample answers and write, you will get the sample answers today, so you don't have to copy these down too, okay? I'll give you all the marking criteria and the sample answers. These would be your template, basically, for any of the long responses in the module 7. I mean, there are more. I didn't really include the caution postures, the postulate and the theories yet too, because we've done the topic test. So let's talk about some of the relationship between those. Adaptive innate immune systems. The 2 marks goes on to the clear comparison of the innate and adaptive system, including the key features and cell types. Let's talk a little more about that here. So start off with the innate immune systems. The key features in the immune system, this is known as what is called the first line of defense. Defense, as you know. It has all those cells. It has a physical barriers. Like we went through a lot of details about it. Skins, mucous membrane, your tears, or the body fluid, stomach acid. Could be any of those innate immune systems. This is known as the non-specific. And causing that, a lot of things like inflammation due to the vasodilatations, making the redness and the hot regions too. And the cells involved to that is, as we discussed a lot last week, it was about the phagocytosis or all the macrophages. So what in terms of the white blood cells, but let's be specific about white blood cells in here. It's basically a phagocytosis, including the neutrophils and the macrophages. So you can include that specific example of the macrophages, neutrophils, even the dendritic cells. So this is what I call as planning of your answers too. You can write it down in a dot point in the given space on the top too. And what you just need to do is you just need to connect them to make them in sentences too. You're not allowed to leave the dot points in your answers, so you must write it in the sentences and the paragraphs. Yes. No. Well, it depends on markers. It could be risky. It could be risky. It depends who's marking your works too, because marking criteria doesn't really specifically say like using the tables. It could be risky, okay? But you can use the table for the planning, because like if you make a table, you're highly likely you're making it in the dot points forms too, which is not allowed in the HSC. All right, so that's the innate immune systems too, and as I said, they are first non-specific. I forgot to add that they are rapid as well too. Okay, adaptive. Adaptive immune systems. So this is basically very specific, but kind of slow. It takes a days to activate that too. And it's very specific as well too, and this is including the cells like all the lymphocytes. Now the reason why we call it lymphocyte is that those out of the B and T cells are coming out from your lymph nodes too. So in lymphocyte we have a B and the C, B and T cells. B cells, B lymphocyte or T cells in that too. Okay, let's actually, I can summarize more the B and T cell in here. Please watch the video if you did attend to last week or revise the things. B cells, we have the plasma cell, which is the one that releases the antibody, the final weapons. It kills all the viruses and the pathogens too. We also have the memory, the B cells. Okay, so adaptive is very special compared to the innate because it's very specific for the given pathogens. They do memorize, or they do like in some adaptives. So they are coming leaving there's some memory B cell and T cells too. T cells would be if you remember the helper T cell was the one things that we talked about too. So helper T cells are the ones that activates both of the B and the T, the killer T cells, or you may say the cytotoxic or killer T cell, which kills that. Now remember that B cells are targeting those pathogens, T cells targeting the infected cells. So it's kind of preventing, or like there is a memory, I forgot to mention that, memory, the T cells as well too. So you're going to relate all that together too. It's good to have some flow charts of all that too and connected here. Now, 2 marks goes on to here then. Explanation of how each system functions in response to the infections too. So you got to talk about each of those systems, and the last 2 marks goes on to evaluation of the importance of their interactions. You're not just talk about what they do, you need to talk about what how they're interacting to. So I describe that as innate immune systems get activated every single time, whilst we get the adaptive immune systems too. Does that make sense? So they have to be interacting with each other too, because innate response, basically, one, innate immune system, first of all, triggers the adaptive immune systems. There's a starting point. 2, the coordination ensures the rapid initial response, as was a highly targeted too, and also be like longer lasting defense too. Especially for the inflammations, that's our vasodilations too, they are keep supplying the lymphocytes into the sites of the battlefield. So that means what? Without these, without the innate immune systems, or in our defense systems too, we won't get the adaptive immune system, or we won't get the prolonged adaptive immune system as well too. Okay, so this is a kind of type of question, easy to get 4 out of 6, but kind of difficult to get 6 out of 6 because many students actually forget about interacting. Talk about the relation between the two as too. Okay, just be aware guys, okay, biology, the 2 marks is crucial. It's really crucial because the raw mark with the biology to get a band 6 would be, I would say, the high 80s. And 2 marks out of 100 is really, really crucial too. Yes, Hayden. One interaction. One interaction, 1 mark. Okay, next one. Question 2. Explain how the body immune system responds to the viral infections and analyze the implications of their response to the public health strategies such as vaccination. We'll talk a little more about the public strategies and the vaccination today too. But 2 marks. Basically, like you can relate it to the adaptive innate immune systems too. So 2 marks goes on to the clear description of the innate and adaptive immune response to the viruses too. So relate these again. So I would say this is kind of compulsory to you need to memorize them first of all. 2 is accurate explanation to the roles of the B cell and T cell and the viral defenses too. So how do they actually activate it and kill the viruses that get infected? You need to talk about the B cells are, again, it's targeting the viruses directly too, due to the you release the antibodies. T cells, especially cytotoxic T cell, were killing those infected cells. And this is crucial for the virus. If you think about how the virus gets spread apart in your bodies, unlike the bacteria, the fungi, viruses injecting the some nuclear materials into your cells, making the cells get infected and growing that kind of like a virus again in the cells too. So the role of the cytotoxic T cell for the viral infection is crucial because they can kill that cell that is infected by the viruses too, which means that they can prevent the further spread of the diseases in your body too. Be specific about the type of the virus, the pathogens you have. The reason why the question specifically asking about viruses here is that we want to see the answer that how the viruses can be spread apart in your bodies too. If that's a bacteria, the fungi would be different by the way too. They would not actually, they would kill the infected cells too, but not as serious as the viruses in case of this. Last 2 marks goes here. Effective analysis of how immune knowledge informs the vaccination and the public health strategies. We will talk a little more about these in the details about these too. Why we need to get a vaccination for the flu seasons like this. Has someone get the vaccination yet? Flu vaccines? I need to get one next week too. Okay, we need to get one, and I explained the importance of that as well too. Your school probably give the vaccination when you go back to schools as well too. Okay. 3. So basically question 2 is covering that too. Oh, not this one. 3. Describe how pathogens can adapt to host immune systems and assess the impact of these adaptation on the development and spread of disease in the human populations too. This is the adaptation part that you need to relate it to how just the disease gets spread to it, how to get adapted to it. We covered it in chapter 1, a little bit of that, in the adaptation of those pathogens too. Now, pathogens get adapted to. So 2 mark goes into the description of the adaptation mechanism, such as antigenic vaccination or the resistance. 2 key words you need to remember for this kind of question is, 1, there are always be pathogen, whether that's a bacteria, viruses, fungus too, they have a really rapid rate of the mutation. Okay, think about why. Like a bacteria, for example, they are prokaryotic. Aaron, prokaryotic bacteria. What kind of the reproduction they go through? Asexual means that they're just cutting in half and covering that too. If there's something happened due to any of the mutagens, yeah, you got to relate it to any mutagens too. Could be a chemical, could be a physicals too, UV light. If there's something happens and they go through asexual reproduction, they don't need to go with sexual reproduction, which means they cut in half and just produce themselves too. The rate of the producing themselves so fast, so if there's a mutation happen, the mutation rate will be so fast as well too. Why is that very important? Now, this is a time that you need to relate it back to what we learned in Module 3. This is related to, then, the genetic variation in their pathogen in a population. If you haven't heard that before too, yes, this is all about what? The natural selection given to. As the older pathogens have the really rapid rate of mutations too, they now have a lot of the genetic variations in the population. So what would be the selective pressure or selective factor? It is your immune system. Your immune system is working as the selective factor, or even for the antibiotics or antiviral medication. So in case of that selective pressure, or the factor would be the human immune system, or it could be like antibiotics, any of the medication, or antiviral, the medications in case of that too. Which means, due to they have a lot of variation in the population, some of the bacteria, some of the pathogens would not get killed by those immune systems, your B cell and T cell, would not get killed by the antibiotics. Then, after they're all eradicated adults, but except the one that's not really get killed by the antibiotics or the immune system, what they do, they reproduce themselves. Really fast rate as well. Let's see outside, okay? Which means what? They're going to raise up the population of that very specific genotype, and then what happens to your bodies too? You get infected again. Does that make sense? Okay, yes, Aiden.
Does external medicine count within the immune system?
Yes, because when you're sick, think about it, guys. When you're sick, when you're ill, you're not just sitting down and lying down until they get healed too. You probably get the help of the medications too, whether that's it could be a Panadol. But that's basically something healing the pain. You may a lot of times they get antibiotics. So it could be any of those too. All right, this is the things that you got to consider about these questions as well too. So again, Module 3, the evolution, natural selection. I'm talking about gene pools in here. Okay, some selective pressure. Evolution, natural selections, it can be related to the antibiotics, it can relate to the infectious diseases too. Make sense? Okay, the last question. Compare an example of the historical disease management strategy with the contemporary approach and evaluate the effectiveness of each in reducing disease transmissions too. Now, we haven't done this yet, so I don't expect you to answer that question, but after finishing today's module 5, chapter 5 of the module 7, we're going to finish most of the module 7 today. You will be able to answer that, but one thing that you can relate to these is, as we had an experience of the COVID-19, think about what happened. This is actually a really good case study because before the COVID-19, they didn't have any experience of the pandemics. Now we do. We all have the experience of that. We have the era of the COVID-19. Think about what happened. We went through all the pandemic, means that you're not able to come out from your house. You didn't go to school, okay? So if you enjoyed that, okay, you didn't enjoy any of the physical activities outside of the world, outside of your houses for two. Okay, personal hygiene was very important. Vaccination, I believe you all got the vaccinations as well too. Now we're going to talk about that in much more depth and details too, in case that we may have another case of the pandemics. You never know in our life, in our futures too. Okay, so leave that question for now. We're going to discuss that in detail steps in your chapter 5 today. So please open your workbook. Page 134-35, please. Okay, chapter 5 is all about then how do we prevent, treat, and control those infectious diseases too. So let's start with the prevention part. Page 136, please. When I'm talking about the prevention and treatments too, guys, think about what we have done in the COVID-19 era. That's how do we prevent them too. So, prevention, if you think about the infectious diseases too, so we need to understand the enemy, which is the infectious disease or the pathogens. We have to understand that to prevent, first of all. Okay, Liana, how would you describe the pathogens, regardless of type? Like it could be a bacteria, viruses too. How would you describe the pathogens? Foreign. I mean, the pathogen characteristics. Especially, pathogen means that for all other infectious diseases, yeah? So what can we describe? What would be their characteristics? Not too sure. Hayden? Characteristics of the pathogens.
Not the types, right?
Not the types, regardless of types.
They cause sickness.
They cause sickness?
Yes.
What sickness? What disease? Infectious. Now, what's the meaning of the infectious? Can be transmitted, or can we say they are spreadable? They're highly likely spread and really fast rate as well too. Now, this is why we separate the module 7 and module 8, non-infectious and infectious too. If you have like someone get skin cancer, it doesn't mean you get to get a skin cancer next to you too. Infectious disease, you need to understand the enemy in here. This is highly likely spreadables too. They're highly likely to be mutatable. Okay, as we described that, there are quick rate of the mutations too. And especially a transmission is, so this is related to transmission. It's something that happens all the times too. So you got to think about here, how do we prevent them? What do we mean by the prevention of the infectious disease? Prevention of the infectious disease simply means that we are preventing any of those transmission of the pathogens too. Spreading apart of transmissions too. Does that make sense? Okay. This is the reason why for the prevention of the infectious diseases. Where's my blue pen? No. For the prevention here, so for the prevention, for the transmission of the diseases too, it happens in the local area, regional area, and time to time go to global areas too. Because think about the population we're living in. Okay, think about local areas there too. So this is related to your question 1 on the page 142, please. Explain why disease transmission needs to be dealt with the local, regional, and the global levels too. The reason for we have to deal in 3 levels there too, you can imagine that local, smallest, regional, bigger, the global, like the biggest on the earth too. We have to do that. So all levels because that they are really we have to do it as the pathogens. As pathogens are spread quickly spreading in a population to another population. We have to manage that in 3 levels like this. So let's see what happened in each of the levels first of all too. So local area. In local area, so this is basically what we do, the early detection. Like a flu, we are counting how many people got a flu in given local area. I'm talking about counts as could be too, can be town. Okay, and then also it means that as we can early detecting that, we can respond. Okay, help contain the outbreak. Good example. If you're sick, your school will not ask you to come to school. Okay, you may get like permission that you need to bring some medical certificates too, but especially if you have a flu or the viruses too, you're not actually allowed to come to school. You're banned because in the local region of the schools too, we don't want to get spreading apart of those diseases. And then moving on to the higher level, which is regional area, but sometimes it outbreaks whole the regionals too. Could be like a whole the states, could be whole cities too. Means that we need to then, if you think about schools can outbreak too, and things happen. Then we are coordinate with the different schools or the different regions too. So coordination. Okay, between the communities. Okay, and then basically what we do is we are sharing the resources. That resources could be some things like it could just be medical resources too. Also be some datas. Okay, and public health. We can also use public health, the messagings. Stay homes, if you're sick, wash your hands, and also be using the hospital capacity. So if you remember the news that we don't have the beds and remain for during the COVID-19 seasons too, from time to time from the one region or two, we send this patient to other regions by just sharing the some resources in case of that. But very unfortunately, if that outbreak goes to the global levels, due to people in catching the flight and on the cruise ships, we remember the case scenario of that too. And what happened is it goes to one country to another country, and that's kind of spreading whole globally too. This is called a pandemic case. In case of that, we need to have do something about global levels too. So international travel. It's a global level due to the international travel and trades. Which means that we need to global surveillance. We also communication, and then cooperation through the WHO, the World Health Organizations, to prevent the pandemics case of that too. What I mean is, if we see this is why we have a really secure and also very strict border lines, border securities too. Testing for if you ever watched some testing for your body heat the temperatures too, telling that if you're sick, you're not allowed to come into the countries too. Okay? And we also share the information that, hey, we have an outbreak in Africa, we have an outbreak in China, in India. We get some information from the countries too, so that we are aware of that, what type of diseases that now are spreading apart. This is why, this is one method that we are preventing it. Does that make sense in terms of understanding that? Okay. Then, what about the factors? What could be the factors that's transmitting those pathogens? So again, we need to understand the enemy to prevent that too. Question 2, please. Next page. List factors about the pathogen that affects the rate and extent of the disease transmission step 2. We kind of covered that in the module chapter 1 previously too. So one thing that you need to understand is how do they transmit it? In other words, the mode of transmission. How they are transmitted. Are they like, for example, are they transmitted by the vectors? Vector as in like vector-borne, as in like the mosquitoes, mice, birds, could be the vectors too, or it could be by the airborne too. Airborne is like transmitted through the air, or it could be the waterborne, transmitted through the waters as well too. But that depends on the type, depends on the mutation of the types of the pathogens as well too. And also infectious, the dose is something that's very important. So what I mean by the infectious dose is that the minimum, the number of the organisms, okay, required to cause the disease. Even now, probably in this room, I would not say like, we don't have, it is clear. It's not really, this room is not really sterilized. Means that, yes, I must say, we have some of the pathogen in this room as well too. Even if you go outside there too, there is some pathogens. You never know, we might have some COVID-19 virus in this room as well too. Or probably outside of these buildings. But the reason why you don't get sick from those pathogens anymore is that first, you're immune to it. 2, the amount of the pathogen we have that in our environment will not be something enough to cause the diseases yet. Okay, so we need a certain number. Otherwise, if we have a small number comes into your body, your innate immune system get activated, and you have memory B and T cell, which can kill that really quickly as well too. So you're safe for now. Okay, another thing is that in terms of the reproductions, the reproduction or reproduction rate of the pathogens too, how fast they reproduce themselves, and also related to plus incubation period. Some of the pathogens can be like spread invaded to your body, just stays there for a while, and then just got spread apart in your bodies too. We call it incubations. Okay, and also this is related to the mutation rate, how fast they are mutated in your bodies as well too, and plus that too, this is got to relate to the resistance. Therefore, to the treatments. Okay, so those are what we believe that as what we need to be concerned before we think about the preventions too. So, prevention is pretty easy if you understand that. What I mean is this: if we understand how the disease gets transmitted, we just need to control that. For example, vector-borne. If that's all about the let's say mosquito causes the dengue fevers. So what do we need to do with the mosquitoes? We kill them all. Using some chemicals kill them all too, or using some of the some biological tools. If we know it's airborne, what do we do for preventing the disease? This is why you were wearing the mask, okay, to prevention the filter the air for the pathogens too. What about water? This is actually a common cause, especially in the developing countries a lot of times too. The water is kind of contagious, contagious. It's basically pollutants too. So what do we need to do? We need to build up the good sewage systems, as well as clean up the water, filter the waters as we go too. Okay, so a lot of times you may have some the sickness from the waters in the developing countries because water is now clearly filtered from the public water systems. Yep. Are you urgent? Or burst? About to burst? Hurry up. Question 3. Justify why the correct management of the environment alone could have the potential to eradicate infectious disease in the area. Use an example of that too. So this is basically same as here, what I just described here. If we understand any of those, that how the disease can be like transmitted. For example, as I said, vector-borne due to like mosquitoes. If we just eradicate all the mosquitoes, you won't get disease. It's a very simple as that. So the key point of this question is know your enemy, then you can prevent that easily. If you don't know, but the reason for the COVID-19 was spread so a lot really fastly too, because we didn't understand the characteristics of that virus specifically. And in the lab, in pathology, it took a while. It took like a month to investigate the COVID-19 and what are the weak of the two. Once we understood like, this is the virus, it can cause that, it's causing like it can be transmitted by the air, okay, also the physical touch, then we all published all the public papers or public health systems too. Okay, so don't worry about the question 3. It's basically a used example of those. Any questions about the pathogens in terms of the how they prevented in a local, regional, global area and the mode of transmission? Pretty straightforward. I know that too. So for these modules now, you get a lots of those some case study questions in trials and HSC. They won't just give you the questions like, hey, why we need to prevent that. They won't give you questions like that. So if you haven't tried like an HSC question that I gave you, you probably haven't seen the rabbi questions. The dog bites that too, and the infectious disease. Try to relate to that too here. This is something that kind of interesting if you like to if you're enjoying those case study questions. And you better enjoy it in terms of that. Try to make it find it fun from understanding the disease type and think about how you're going to prevent that too. Any questions about these for now? Straightforward. Okay, let's take a little short break and then we're going to come back for some more questions and the chapter. Let's talk about then how we specifically prevent the spread of disease. First of all, if you haven't learned that, how to wash your hand properly, or like personal hygiene, the importance of why we need to wash our hands clearly too. Yes, there's one thing that we have to think about it too, because the mode of transmission of most of the infectious diseases by the physical contact. So whether they're your handshake, kissing, hugging, or like any sort of physical contact. So there's a reason why a lot of times if you're sick, your family members get sick as well too. Not only that, your hands can carry the germs and you're touching everything in your household, in your schools too. And if someone touches that, put it in their mouth or put it in their any of the holes, then you can get the diseases too. So personal hygiene, like hand hygiene, is something very important. So you probably haven't learned how to wash your hands. Like you should wash that for good 10 seconds too. I believe that no one's actually doing that nowadays too. But still, it's a good practice. I believe that in hospitals, if you watch the medical dramas, surgeons actually scrubbing their hands so thoroughly, so that preventing any of these the transmission of diseases too. Okay. Second thing is that we are using the quarantine. Now quarantines basically it could be happening in any of the levels. So it could be local level quarantines, regional quarantines, even for global quarantines too. We all experienced that from our COVID-19 basically too. We started from the local quarantine. So if we see the case in let's say Ryde or in East or Napping, then what they've done is in New South Wales government that they just stopped, they quarantined the whole region, that regions only. And they realized that disease spreading so fast, it went to the Bankstown, went to the city now too. So what they have decided is they shut down all the borders too, all the regions to regions. It was kind of interesting, but in the same time kind of stupid. Because think about, you're not allowed to go you're not allowed to drive for 10 kilometers from your households too. And the police were there and checking for your driver's license and checking your house and the home address, everything too. Unless you're in the medical an emergency or you're in something to do. Okay, work, you didn't need to go to schools. I didn't need to go to school for my work as well too. So everything was online too. So that was basically a quarantine. But it's basically If that is so extreme, especially like infectious dose and reproduction rate is so serious, like really significant, especially the mode of transmission is something unable to control, they take the really extreme method of the quarantine like this too. And similar things happen even now too. So if you get a flu, which is a viral, or the influenza, you are quarantined by yourself in home in your rooms. You're not allowed to come out too. So it's kind of stopping the spreading of the diseases as well too. Okay, so that's fairly easy because we all have experience of that too. Third, probably the most important thing is the vaccinations. Yes, vaccination is painful. Who likes needles? There's no one actually likes needles too. But you all need to get soon when you're going back to school, most likely too. School will give you like vaccinations now. It's the flu seasons. Every year, but have you ever wondered that? Every year you need to get the flu vaccines. Well, it doesn't have to every year, probably like every second year you need to get the flu vaccines. Have you ever wondered why? I mean, have you ever wondered like why you need to get a zap every like a year? Couldn't that just be like the one that we got like last year could be like just enough for this year too? Now, the reason why we need to get the vaccination pretty much every year is because of this reproduction and mutation rate of the pathogens, especially the viruses too. Yes, the vaccination you had last year will protect you from the very specific type of the pathogen last year. But what happened during the 1 year, the period? Now, incubation period of the viruses as well as mutation rate, the fast mutation rate, kind of giving the whole different set of the mutations, or whole different set of pathogens now born in this year too. So what the government, New South the health governments do is they are in the pathology lab, they are investigating what type of mutation we are more common in this year and creating the some vaccination for that. So that you can get infected, but you're not going to get sick, not as much as like last year's too. But if you don't get a vaccination, you may get more sickness and highly likely spreading diseases too. So how does vaccination works? To understand the vaccination, we need to understand the graph. Page 150, please. You haven't seen that graph when we talked about the adaptive immune system. So this is basically showing the graph of that. When you are first get infected, primary infections, okay, in terms of the level of the antibody in the blood, get gradually increasing. Remember that there's a days given. So once you first get sick, get infected too, it takes about 5 to 10 days to maximize the antibody production in your bodies. And this is true that if you understood like it's an immunity, adaptive and immune system, because adaptive immune system needs to be awakened by the innate immune system. You can think about the helper T cells too. So it takes a really big, long period of time to activate that primary immune response. That's the maximum antibodies too and really produce. And what happens is basically those will kill all that pathogens. And once they kill the pathogens in remaining your bodies too, they are decreasing the antibody productions. Then what happens is they are leaving the trail of the memory B and T cells too. Okay, so what happens after if you get a second invasion, the second infection happens too? If that's the same type of the pathogen embedded to your body, because we have a memory B and T cells, we have a sharp increase of the antibodies like this too. So this is called the secondary immune response, which is very fast and stronger. In terms of that, the antibody they release the stronger antibodies to eradicate, to kind of stop the spreading the disease spread apart too. Okay, this is a natural, by the way, natural what happened to your body. And somehow we understood, humans, like especially started from the pustules, we understood that how our body get immune to those kind of diseases too. So we are kind of replicate that. We're going to use the response using that something known as the vaccinations. So vaccination graph, page 151 shows like this. This is the vaccination graph. Now don't get confused guys here. This is the vaccination graph. This is a natural your immunity response to. What you'll be able to see that both is they're having very similar or the same graph shape. Because the whole purpose of the vaccination is that we want to replicate, we want to copy that natural immune response of your bodies too. So what happened is this. You get the first injection of vaccines. Those vaccines are made with the two types. It's either be the dead body of the bacteria, dead body pathogens, or they weakened the pathogens of that kind. Then what happens is your body get immune, you've got to get started to get release the antibodies, B and T cells. And what they do, they kills all that small amount of these dead bodies of the bacteria or the pathogens. It could be the viruses too. Then what happened? You have maximum amount of antibody release then too. What they've done after kill all that, they're leaving that memory B and T cells then. And this is the key point. They're leaving the memory B and T cells. Why is it very important? Because if you have any like injections or like something like happens to, you may get more of that too. And then what you do is we get the booster shot. Yes, for the COVID-19, I believe that you had at least 2 sets of the vaccinations too, sometimes 3 or 4. The booster shot is basically like increasing the total level of the antibodies in the blood remain too. Now what does happen? For a prolonged period of time, you have a good amount of antibodies remain in your bodies. What does it mean? Now, this is very important that if you get an infection or the pathogen invaded to your bodies too, due to a lot of the antibodies remain in your bodies, they will kill the infectious pathogens straight away. So you won't get sick not as much as before too. This is the whole purpose of vaccinations. And we call those, known as some artificial active immunity. The one before was known as the natural active immunities, simply using your own immune systems, and we are basically activated by the pathogen invasions. Artificial active immunity is something that we use in the vaccination with dead bodies of that too. So let's summarize that next page, 152, for the active and passive, natural and artificial immunities then. Okay. Started with the active. It's basically what we said as active and the natural, the activation of that too. This is simply known as the adaptive, the immune system, immune response to of an individual. Okay, and this, as we know, has the immunological, the memory, using the memory B and T cells, and also the very long-term protection. Then what about artificial, the active immunities? This is the vaccination that we're artificially activating your immune system. So vaccination to activate or stimulate an adaptive like an immune response. This is basically the same as the above. It has the immunological, the memory. It also has the really long-term protection as well. Those are known as active. Now, what about passive? Okay. Now, passive naturally is generally happens during the pregnancy. Okay, passive as in like the passive transfer. This is the passive transfer of the antibodies from mother to the fetus through the placenta before the birth, okay, or through the placenta, or even like before the birth, and from mother to baby, okay, through the breastfeeding. And the things about this is non-immunological memory, or no immunological memory, no immunological, the memory, and relatively a short term. This is one of the reasons why the newborn babies, they don't really get flu. They don't really cut to flus because whilst they are breastfeeding, because mothers are giving that kind of passively giving something, the antibodies through the breast milk. Okay, no immunological memories and short term. Now, similar to that, we also using some artificially passives too. So in case of that, especially like those patients really terrible, really sick. They don't have any immune system. I'm talking about A's in case of this. They don't have any immune system to activate it. Or the leukemia, which is the white blood cell cancer. In case of that, doctors are administering the antibodies. Okay, that have been they are produced by the another like organisms against the specific pathogen. Or the toxins. What that means is we are just drawing the okay, I get the you have a good amount of antibodies, Liana, which means we get some antibodies from you and administrating to the other person who are really terribly sick. The person who can't really produce the antibody themselves due to some reasons too. If they're terribly sick, things happen. If they're old, they can't really do that too. So this is also be no immunological, the memory. It doesn't really have the memory cells, therefore it's got to be a short term of that too. The key point of that is active is adaptive immune system anytime whether that's due to the vaccination or natural methods. Passive would be transfer of the antibodies. Okay, one is from the natural method from the mother. It probably just only happens from the mothers to babies too. Okay, and artificial way, we're injecting the antibodies to your bodies straight away. Question 2. So distinguish between the active acquired immunity and passive acquired immunities too. So what is active acquired immunities? So write it down in your notes as well too, please. Question 2. Active, the acquired immunities. Okay, this is done that. Basically, you can think about any of those active and passive. So whether that's artificial or natural too, active acquired immunity is related that to. See, they involves the immune system. We're using our own immune systems actively, okay, responding to the pathogens, okay, by producing the memory cells and the antibodies. And as we know, this is the longer lasting. It also has the some immunological, the memory of that too. And this could be both active and passive. Active one is simply, the natural artificials. Natural method means that you just get sick and then you get a second infection, so you're not gonna get the same sickness. Or you use the vaccination to induce the same sort of the sickness to leave that memory B and T cells. Okay, passive, acquired, reimmunity is that something that using slightly different too. So this is the involves receiving, basically receiving the ready-made, made antibodies. Okay, from another source. Okay, it is very immediate in terms of the acting, immediately acting, but it'll be only be a short lasting. It doesn't go for long, and there'll be no memory too. No immunological, the memory, because we simply don't have B and T cells, the memory B and T cell for that too. It can also be a natural and all the artificials too, as I give you the table of those active and passive natural and artificial there too. So you should be able to differentiate the meaning of the natural, artificials, active and passive. Time to time they give you questions like compare and contrast of the active acquired immunities, passive acquired immunities. In case of that, you need to talk about both the natural and artificials too, or maybe like natural, active, artificial actives too. Okay, so key terms again. Natural means you're using your adaptive immune system, B and memory B and T cells. Therefore, it'll be a longer lasting and immunological memories kind of remained. Passive would be just a transfer of the antibodies, whether that's from the mothers to the babies or the fetus, or even for you're injecting that antibodies from the foreign organisms too. Okay, straightforward. Anything that way. All right, 3. Distinguish the different type of the quarantines and compare them in tables of that too. So yes, we have a different type of the quarantines. Let's make a table of the quarantines then. And we all kind of experienced that before too. So time to kind of relieve your memories. So the types of the quarantine. Aaron, what was the quarantine? Do you remember we went through?
Like lockdown.
Lockdown, okay. So there's basically a community lockdown, okay. Now, when you're solely, this is individually sick, what were you asked to do?
Stay in a room.
Stay in the room. We call that as self-isolation. Self-isolation, when you're sick by yourself too. Okay, so it's basically the description of that is infected. Infected or the potentially exposed. Okay, individuals. Okay, they isolate themselves. Which is you basically stay in your room. Okay, so example would be people staying at home after close contact too, so you're not allowed to come out. And that was kind of strict at the time of the COVID-19 too. Okay, and then there was time that we had to do the mandatory quarantine. Okay, mandatory quarantine is basically by the government, the health government, or it could be a state or the federal government. The government enforced the isolation at a facility. And that was happens whenever someone's arriving from Australia, from the foreign countries too, they need to isolate it in the very specific facilities. So there was example of that is hotel quarantine. And there was a lot of issue with the hotel quarantine as well too, for the international. the arrivals. How many days was it? 14 days or something? 2 weeks. Whew, the hotels too. Okay, and then we had a higher level of the community, whole community lockdown. What's happened to? So what happened was that the movement restricted in a larger population. I think we had a lockdown in the whole New South Wales for the good a month of time too, so you're not allowed to go out, you stay in your home. Maybe like you have a radius to go out to. So citywide lockdown during the COVID outbreak wasn't something example we can think about in here. Okay, and then this is the extreme levels, the border, the quarantine. You just shut down the border or restricting excuse me, movement across the borders. So it was about the time we actually closed the state or the national borders for a few, I think it's a few weeks, especially from the state to state. It was a time that Melbourne was kind of serious about the COVID-19 outbreak too, so New South Wales kind of shut down the border from the, any flight or the car from the Victoria to the New South Wales. And it was on the news pretty much every day as well too. Okay, so these are the types of the quarantines, and from the single individuals to the greater level. So again, local to regional, regional to the internationals too. Make sense? Understanding that too? So it's not so complicated. Then, during the quarantines, while you are isolating at your place by yourselves too, you probably haven't heard like enough of the news and radios. You guys don't watch don't listen to radio. YouTube videos nowadays too. If you've ever seen the YouTube advertisement saying that, oh, wash your hands, COVID-19, get a vaccinations, that too, kind of advertisements too. This is a part of what we call the public health campaigns then. So what are the public health campaigns? It's basically like you're kind of promoting the people to do something like to preventing the disease of infectious diseases too. Public health campaign has four segments. We call that as RISE. Stands for resolutions, informations, coordination, education. Called the RISE. Okay, it's good to remember the terms RISE. So RISE, resolution, stands for this. Resolution of the in the approach to the RISE, resolution of the governments and the health organization to find a solution to infectious diseases too. Let's go back to COVID-19. What they have done is they found out what the COVID-19 virus is. Okay, they found their source of that as well too. What would be our mode of the transmissions? So they are providing us some information about COVID-19. So we all get educated later on too. I stands for the information informs of the epidemiological studies and scientific studies of the pathogens and its mode of transmission, so that the solution is based on the accurate data. So you know they are providing that too. Like a flu as well too. You know the flu is transmitted airborne. Okay, and then coordination of the efforts of the local, regional, and global scales so that resources are used efficiently too. Public campaign-wise too. And then basically what they do is they're giving some of the, hey, we have a rat test in some of the certain like pharmacies and chemists too. We have this mask providing to all like some who can't really afford to buy them too. And then final thing is education. They educate you in terms of their aware of the type of disease, as also knowing that how to prevent the spread of disease as well too. So it's kind of interesting that the kids are like all of you actually had some education of the personal hygiene too, how to wash your hand. Okay, and it's basically in the school levels too, as well as school levels or in the house levels too, goes to the regional to the international as well too. These are called the RISE approach of the givens too. Okay, so let's have a look at the we use the pesticides or the genetic engineering too. These are something that we use time to time, kills the insects, kills the some pathogens and weeds, if we assume that these are the causing the pathogens too. So think about the some malaria, which is caused by the mosquitoes. We may use the insecticides, which is basically kill all the insects. It's harmful chemicals, but it still kills all the mosquitoes or the flies too. Fungicides, now this is something that we use to eradicate all the fungi too, like basically mold is a fungi as well too. So what we do is we put some chemicals, kill that, because we know that fungi can cause some infectious diseases too from the spores. Herbicides kill the weeds too. Weeds can cause some inflammatory diseases too, so you can cause some allergy reaction from that too. So what do? We kill them. We use the chemicals. That's one mode of the treatments that we can do. Or in a fancy way, we can use the genetic engineering of that too. Genetic engineering, as you remember from module 6, do you remember all that CRISPR? Okay. Genetic mutated things too. So what we do is we are mutating those germs, pathogens too, making them to be less effective, less like spreadable as well too. So that we don't have to worry about to get a self-injected vaccination as well too. Okay? But I want you to think about this one here, the case study of the SARS-CoV-19 in class exercise 5.3. There are questions 1, 2, 3, and 4 givens. Okay, could you try those 4 questions? There are data provided. We're going to discuss about these data and give it about 15 minutes to solve these, to do these questions then. Question 1. What is the aim of the quarantine in relation to the disease prevention? You can relate to the COVID-19. So quarantine aims to 1. Quarantine. Sorry, spelling. It aims 1. It is prevention of the spread of the disease, first of all, of, let's say, infectious disease. Let's be specific here. Infectious, the disease. That's the word. The wrong disease is one prime reasons too, by isolating that too. And this is also be, therefore, they limit the contacts with the contacts with the general populations. Same reason, basic prevention of that too. And this is kind of related to the reducing, therefore, the transmission rate. The transmission rate. And allows time for the symptoms develops. So, and then monitoring the symptoms and also the response as well too. And also it gives us time for the development. So it kind of like it gets some time, it buys some times, provides some times for the management, treatment, and the management as well too. Okay, so this graph shows what happens, the timeline of the COVID-19 that happens. We believe that it started from the 2020 January to the first outbreak was measured in China, probably like in the 19s. And it's gradually, you can see like what actually happened to Australia, the quarantine levels too. So stage 1, stage 2, stage 3 shutdowns too. You all experienced that. Stage 1, basically like you're closing the local levels, move it on to the regional levels, international to the regional to the local levels too. So you all experienced that quarantine in the lockdown, everyone's too. And first easing of the restriction was happened in around the Aprils too. So we're going to assess that whether they were effective or not by looking at the next graph, which is shown on your page 161 later on too. But let's answer the question 2 first. Provide the 2 reasons why Australia is a difficult country to quarantine. Jennifer, why do you think Australia is such a difficult country for the quarantine?
I said Australia imports and exports
Yep.
a lot of resources.
Yes. Just the resources. Think about one of the main income for the federal government. It's the tourism. Okay, tourism is one. It's also the education. It's the main good resources too. So, you're right. We have a lot of those, but it's more about high international. I would say travel volume. Gotta think about yourself. What's your plan for the end of the year? Probably not gonna stay in Australia, even from overseas a lot of times too. Okay, or like you've seen like many like foreigners coming and arriving to Australia as well for the some nice country, I guess. Okay, immigration, migrations, also the travel internationally too. It's very important because it's a good source of money, to be honest too. And then if we're just shutting down international border, we're losing much of the money as well too. So in government decisions too, it's really difficult to make a decision that, hey, let's shut down the borders now. Also the trades, plus that, the high international trade as well too. The trades, also very important. 2. Unlike the other countries too, it's, as you know, Australia is the biggest island. This is giving us that, the geographical isolation. It's one thing that we can end with, but because this is the biggest island, that vast internal like distances. Traveling all around Australia is kind of big too, so it's really hard to close the border time to time. I mean, there's not enough resources, people to closing down the borders too. If there's someone decided to like, okay, let's go across the border from Victoria to the New South Wales, going from near at the side, it's really hard to break based on that too. So it's very difficult to country to quarantine in terms of that 2 reasons. 3. Assess the effectiveness of the RISE approach to infectious disease limitations too. So RISE approach, as I told you before too, the 2 types of RISE, one for the public health campaigns, another for the infectious disease management too. RISE, resolutions, I, information, C, coordination, education. So do you think the public health campaign in Australia was effective? I would say so, like yes, it was controlling pretty well too. Or using that, report, isolate, contain, and elimination. Now, do you remember that, like in the news, like the news is showing actually that, or the YouTube video showing that, hey, we have a person into COVID-19 kind of moving around the cities and they're going to Bankstown, so that those who are actually in the contact or in that regions, in the time, you must self-isolate it too. It was quite a big news at the time too. If you think about it now, but if you have a flu, you can move around that too, but you won't be on the news anymore too. So at the time, I think it was kind of good that we had kind of report systems as well as isolating the peoples to contain the peoples to for like the vaccination and stuff and eliminate until they get perfectly killed too. So this approach was, I would say, very effective in Australia, which is evident from the next graph on page 161. You can refer to that in here. So it's showing you that what happens to the top 10 countries for the COVID-19 infections compared to Australia. Number 1 is United States. What's the number there? 30 million people get infected. Number 2, India, Brazil, Russia. So it was kind of like an interesting topic at the time. United States, one of the wealthiest country in the world, the powerful country in the world, is number 1 in the COVID-19 as well too. Why was that? It was like one of the things that we gotta think about it as well too. It's kind of related to their public health campaign as well too, and in terms of the demographics. Yes.
No free healthcare.
Yeah,
They didn't have it all.
no,
Yeah.
exactly. They don't have Medicare either too. So in terms of vaccination wise, yeah, I mean they don't have the public and the healthcare system at all, unlike Australia. Now, second highest was India. We don't have China, by the way, here because we do not have the exact data for the China. They didn't really they didn't release the data publicly too. So we just assume that they have a higher rate too. India, Brazil, Russia too, in terms of their ratio, the values too. Australia, compared to them, we have 27,000. So compared to these values, this is kind of like a tiny small values too. So somewhat it was kind of working, it was working well, those RISE systems too, even though at the time it was kind of serious about it. Having the 27,000 is a lot of people too. Yes, you may think about the people that are living in Australia compared to the United States and other countries too. India is one of the second highest level of the population densities too, but still, we did pretty good job. And why it was kind of, I mean, it was 2020, we still have the outbreak after 2022, second and third too. So let's discuss that. Was the Australian government response to COVID-19 effective? Let's assess this now, based on the data provided. The data suggests that in the year of the January, December 1st of 2020, Australia has about 2,791. So in case of the number per million, December 1-2, Australia has 1,095 per million infected peoples, whereas United States have the 41,000, which is about the 40%, 41% of the whole population get infected. So comparing to the top 1 or even top 10, which is the India, 6,000 there too, Australia did pretty good job. And you can compare the quantitative values here. Australia has only been like what? Say 1% or 10%? 1 million. It's a 1%, isn't it? Okay, 1% compared to the 40% of the United States. Okay, then why Australia was kind of successful in terms of the preventing or response to the COVID-19? What could be the possible reasons that Australia was having such a low percentage of the infectious people? Rice. Every country did the rice though. What was the distinctive features of the strategy of the Australia government compared to other countries too? You can bring it up some of the other countries if you want to. Like I think South Korea did pretty good job too in terms of the controlling that. But they have a common factors. One is this. They closed the early border closure. Was one of the key factors there too. In terms of the blocking arrival from the high-risk countries, so going back to the data too, they're blocking Australia blocked the Chinese in early, in January. They blocked the entry of the Iranian, South Korean, Italian, because those are the countries that at that time have a high amount of the outbreak. So they blocked that. They actually blocked that. You're not allowed to come in if you have coming from that countries too. The second is they also had started with the Australian border closure and self-isolation of all the arrivals too. So it was quite early the mandatory the hotel quarantine. For the returning Australian or returning travelers. Okay, and then we had a lockdown, which is stage 1 to 3, the shutdowns. Can't remember what the shutdowns are. I think we have data provided. Memories, shutdowns, as in step 1, roadmap safe of that too. Yeah, it's kind of given all that. And we have a good public health, the campaigns. in terms of the educating the people too, and also like using all that right strategies too. You always get like get information about COVID-19 every day, pretty much all the sources too. Whether we're talking about social media, Instagram at the time, it's full of the COVID-19 information as well too. So they it's basically working in the government levels. What I mean is the government was kind of to negotiate with those social media companies. They asked them to publish those papers, publish those information about the COVID-19. So you all are aware of that, even though you didn't watch the TV or even the radio, not hearing the radio at the times too. There's a bit of like this. They're also good support for the healthcare. Okay, and healthcare services. And they contact tracings too. And they contact tracing. Has anyone been to the COVID-19, the center, where you get a sick too, get the swab, nose swab? Yeah, has anyone done that before too? I mean, that's a red test, actually going to center or the hospitals too. Now, did you pay for that? You didn't really pay for those kind of swabs too. This is basically one of the good things in Australia because you didn't need to pay for those kind of identification of diseases too. Some countries, they actually pay for each of the swabs because they're actually quite expensive, as we know as PCR test. Now, we all know what the PCR stands for too. Okay, the red test, even there, red test, I think the schools provided the free red test too, in cassettes of that. Cost of that is pretty magnificent too. So they spend quite a lot of money to that. Australian government's willing to pay for that too. So it is the result of that. We are able to control that quite in the fast period of time compared to other countries too. China and India control like that for a really long period of time, even after we get some vaccinations too. Australia is one of the first country get the vaccination from the companies earliest. After the, I think it's the US, and then followed by the Australia, UK too. Okay, so this is what I mean by the some kind of case study. Like COVID-19, we had one question in 2020 and 21, so I don't think we get the same question again in 25 in HSC. But as you all have experience of the COVID-19, it's a good strategy to study these infectious diseases too. Reflect yourself. What happens to that period too? What happened? Like how did you get something healed? You don't have to talk about the symptoms in here. How do we hear about the COVID-19 and relate it to the public health campaigns all the times? And then once comes after, we all get the vaccination of that too. So I show you one video, actually two, about the vaccinations, that how the vaccination can help us too.
10,000 years ago, a deadly virus arose in northeastern Africa. The virus spread through the air, attacking the skin cells, bone marrow, spleen, and lymph nodes of its victims. The unlucky infected developed fevers, vomiting, and rashes. 30% of infected people died during the second week of infection. Survivors bore scars and scabs for the rest of their lives. Smallpox had arrived. In 1350 BC, the first smallpox epidemics hit during the Egypt-Hittite War. Egyptian prisoners spread smallpox to the Hittites, which killed their king and devastated his civilization. Insidiously, smallpox made its way around the world via Egyptian merchants, then through the Arab world with the Crusades, and all the way to the Americas with the Spanish and Portuguese conquests. Since then, it has killed billions of people, with an estimated 300 to 500 million people killed in the 20th century alone. But smallpox is not unbeatable. In fact, the fall of smallpox started long before modern medicine. It began all the way back in 1022 AD. According to a small book called The Correct Treatment of Smallpox, a Buddhist nun living in a famous mountain named Shan in the southern province of Sichuan would grind up smallpox scabs and blow the powder into nostrils of healthy people. She did this after noticing that those who managed to survive smallpox never got it again. And her treatment worked. The procedure, called variolation, slowly evolved, and by the 1700s, doctors were taking material from sores and putting them into healthy people through 4 or 5 scratches on the arm. This worked pretty well, as inoculated people would not get reinfected, but it wasn't foolproof. Up to 3% of people would still die after being exposed to the pus. It wasn't until English physician Edward Jenner noticed something interesting about dairy maids that we got our modern solution. At age 13, while Jenner was apprenticed to a country surgeon and apothecary in Sodbury, near Bristol, he heard a dairy maid say, "I shall never have smallpox, for I have had cowpox. I shall never have an ugly pockmarked face." Cowpox is a skin disease that resembles smallpox and infects cows. Later on, as a physician, he realized that she was right. Women who got cowpox didn't develop the deadly smallpox. Smallpox and cowpox viruses are from the same family, but when a virus infects an unfamiliar host, in this case cowpox infecting a human, it is less virulent. So Jenner decided to test whether the cowpox virus could be used to protect against smallpox. In May 1796, Jenner found a young dairymaid, Sarah Nelms, who had fresh cowpox lesions on her hand and arm, caught from the udders of a cow named Blossom. Using matter from her pustules, he inoculated James Phipps, the 8-year-old son of his gardener. After a few days of fever and discomfort, the boy seemed to recover. 2 months later, Jenner inoculated the boy again, this time with matter from a fresh smallpox lesion. No disease developed, and Jenner concluded that protection was complete. His plan had worked. Jenner later used the cowpox virus in several other people and challenged them repeatedly with smallpox, proving that they were immune to the disease. With this procedure, Jenner invented the smallpox vaccination. Unlike variolation, which used actual smallpox virus to try to protect people, vaccination used the far less dangerous cowpox virus. The medical establishment, cautious then as now, deliberated at length over his findings before accepting them. But eventually, vaccination was gradually accepted, and variolation became prohibited in England in 1840. After large vaccination campaigns throughout the 19th and 20th centuries, the World Health Organization certified smallpox's eradication in 1979. Jenner is forever remembered as the father of immunology. But let's not forget the Buddhist nun, dairymaid Sarah Nelms, and James Phipps, all heroes in this great adventure of vaccination who helped eradicate smallpox.
So this is how we use the vaccination to do. So it's not just the smallpox; it's all of the medications too. So it seems like vaccination is a king. It's always to be good, but we have to be aware of some of the ethical issues of the vaccinations too. So we have to hear about those people. Actually, you have heard about those groups called the anti-vaxxers. Okay, so this is actually interesting debates between the two.
I wish there was just more compassion. No, we don't want to make something difficult. We just want to be acknowledged. My daughter was a victim, and she's being punished.
Hi, my name is Marissa Gold. I am a parent. I have 2 girls, 10 and 13, and I'm also a parenting expert with my own parenting company, Intuit Parenting.
My name is David Epstein, and I'm a pediatric intensive care physician.
I'm Gary Schliver. I'm an internal medicine physician.
I'm Bob Sears. I'm a pediatrician. I guess my greatest passion is just to help encourage full, complete, informed consent for vaccinations.
I'm also Marissa. By trade, I'm a designer. I am also an activist and a mother.
I'm Melissa Floyd, and I would consider myself an informed consent advocate. I just want to make sure this conversation can be open for people and continue to inform people and to listen to everyone, understand why we each come to our opinion on this.
The first statement is, I am vaccinated.
So I actually wasn't fully vaccinated. Interestingly, I grew up with 2 parents that were into alternative medicine. So I was not vaccinated as a child, but as I got older, I vaccinated myself.
Well, I was vaccinated as a child, but my last vaccine was about 15 years ago when I returned to college, and I had a severe reaction in that I became arthritic in my hands. Went to many, many doctors, and nobody knew what was going on and why it was happening, and just shrugged like, it doesn't make sense. You're too young to have arthritis. And it wasn't until having kids and sort of digging into my own research for them that a lot of answers started coming up, and I think it's unfortunate that a lot of it is overlooked.
For me, and I'll continue to get vaccinated regardless of the risks, because I've seen too many things on the other side. I've seen kids, come into the ICU and die from getting the flu. I've always felt like the risks are far outweighed by the benefits of getting the protection.
Not getting vaccinated endangers other people.
I will acknowledge, of course, as a pediatrician, I know vaccines work. I know they give you protection, but they vary greatly in what that protection is. It's not like 100% magical shield over you completely. But I do acknowledge there are some vaccines like the measles vaccine and the chickenpox vaccine that honestly, if you don't get those vaccines, yeah, you do risk catching the disease and passing it to others.
It's such a complicated topic, vaccines, and you're starting to get micro with each individual vaccine, and definitely the question was talking about the big picture, and I think, yeah, if you get micro, probably some of these vaccines.
I think when you're giving kids medication, you have to get micro about it. I don't think it's doing your kids any service to just say vaccines are all made the same and they're all safe and healthy and good for you, that everybody's benefiting from it, because that's false. It's
Well, we
not
study
true.
them. Before we release them to the public, we study them, so we do know they're safe. That's the thing, is we...
Safe-ish.
Well,
Safer.
Being an intensivist, I see the worst of the worst, and so seeing the other side of kids who don't get vaccinated, I saw a kid walking with meningococcemia, which I haven't seen in decades. He had all 4 limbs cut off. They had to be amputated because it was all dead tissue. And you forget how bad things were before we had vaccines.
I didn't step forward for that because I don't like the assumption that if a child is unvaccinated, somehow they are of risk to everyone. And also knowing that vaccinated individuals can also be carrying and spreading diseases. I think it's very polarizing to separate the two, as if you're vaccinated, you're totally fine. You're not risking anybody anything. Unvaccinated children don't just have diseases hanging out in their bodies waiting to unload at any moment. Anybody could be spreading diseases, especially things like polio and pertussis that are not completely covered by the vaccine.
I'd do anything to keep my child safe.
I agree. I don't have kids, but when I think about it, the idea with vaccines is you're protecting all of us. You're protecting the group. There's this idea of herd immunity. And so I think that's why it's really important to talk about, because this is an issue that doesn't just affect you, it affects everyone around you. Because there's people that aren't vaccinated that are sick or have immune issues, or they're too young to get a vaccine, and they count on herd immunity.
I think most people too, I started out vaccinating my daughter because I believed all the same things that you said. It wasn't until she had a reaction, and several reactions, that I actually had to look at it differently, where I realized by continuing vaccinating for her, that actually would hurt her. And yet everyone wants me to do it for the population, as if I'm supposed to continue to sacrifice my child for everyone else.
Well, there are medical exemptions for vaccine. If your child has a reaction and there's concern, I think that's valid, but I think a larger population is using other justifications to not get the vaccines.
A number of families who look into vaccines, they'll decide to opt out of vaccines because they feel they are just not willing to risk the side effects.
But the side effects are like 1 in a million, 1 in 2 million. Whereas the side effects from the diseases, when I see all these outbreaks and things like that, I'm going to choose vaccines every time.
And that's, I think, right there is the disservice to this conversation, because it is a risk-benefit analysis, and what's unfortunate is how downplayed those risks are. I only started investigating vaccines because I ended up with a kid with an autoimmune disorder. So what does that mean? And instead of finding answers, I have more questions. And 1 in a million is not a real number. It's really not. And so the more that is put out, it's just so people think that, no, it's not when you're talking about a different kind of reaction.
I think the number you're referring to is anaphylactic shock. The anaphylactic shock is, of course, extremely rare. Whereas when you look at seizures from the MMR vaccine are 1 in 3,000.
But again, it creates fear.
We worry that you get that those on your side kind of downplay those.
So my daughter had seizures. Seizures for most people are considered kind of a big deal. When it happens to you, that downplayed element of, well, that's not anaphylactic shock, it's just a seizure. It is just a seizure. But seizures can be dangerous.
I don't think it's an idea of downplay. I think it comes back to what we were saying with the risk-benefit analysis. analysis. And I think the data is very clear that the benefits of giving vaccines by far outweigh the risks. So I don't think it's a question of downplaying the risks. They're there, but we also know that children were dying, and now they're not. And yes, there's side effects, but they're not as bad as what we had before vaccines.
I don't always trust my doctor's opinion.
Okay, this should be enough for now. So if you hear that some opinions from the anti-vaxxers too, I would not say the vaccination is always the right things to, because especially like there are parents having children like having like huge severe side effect from the vaccinations too, and things happen. If the chances of one in a million, you could be 1 in a million too. So you can't forcefully saying that, oh, you have to get a vaccination for the sake of others too. So this is what I leave that as ethical issues behind, because in the child care is basically if we have a policy called no jab, no play. If you don't get a vaccination, you're not able to play too. So the same thing's got to be happening in schools too. So you have no right to say no to the vaccination given the schools, by the way too. It's like mandatory and compulsory too. Unless you have a severe reactions towards the vaccinations. That means you need to have some medical certificates, say the exemption of the vaccination at the times. Now, I'll just leave that for the question mark in here. There's no right answer. This is still debatable too. There are people with the anti-vaxxers. Even for the COVID-19, it was kind of a big issue at the time. And people are criticizing those people who did not get vaccinated. But we can't just say there are no to all the times in case of this too. So I just leave that to ethical concerns for the vaccinations. But it's clear that from the last statement, vaccination, is it working? Yes. Has been working? Yes. So are we going to do that continuously too? Probably yes too. So the key point of today's class is you need to understand, yes, immunity, which is based on what we learned from the last week too. But I want you to think more about your real day examples of whether that's talking about vaccination or typical type of the diseases too. This is something that kind of could be interesting. So out of the field, sometimes examiners of ourselves can be a little more creative to giving the question related to that too. Okay, so I just leave that for now. Homework for the next week. Just 2 things to give you. This is a sample answer for the questions that you answered today. So we include the marking criteria, and I like a short sample answer. I wouldn't say this is a perfect 6 marks, but it's worth it. And homework for the next week, kind of thick worksheets, but it's good revisions. It's handy. Please finish that and handy by next week. And that's all for today. Have a good Easter. Grab a lolly on the way out.